In this video, we're going to go through the cardiac cycle, and that's going to include the main stages of the cardiac cycle, the flow of blood through the heart, the pressure changes, and what's happening to the valves. So I hope you're going to find this useful for paper 1 revision. Let's start with the 3 stages of the cardiac cycle. You should be able to name them. So the first stage is atrial systole. And remember, systole just means contraction, right? So atrial systole is when the 2 atria contract simultaneously. Then we've got ventricular systole. So the 2 ventricles contract simultaneously from the apex or from the bottom upwards. And then we've got diastole. Diastole just means relaxation, so all chambers relax at the same time. They're the 3 stages. Before we get into the cardiac cycle and how this all fits together, let's check we can label the structure of the heart. So let's go. This is obviously the right side, and this is the left side. It looks like it's the wrong way round, right? But remember, you've got to imagine that heart inside your body and make sure you're labeling it correctly. The other trick is that if you look at the wall of the left ventricle, which is here, it's going to be thicker, right? Because the left ventricle has to contract with enough force to create a high enough pressure to send the blood all around the body. So the left ventricle is going to have a thicker wall. That helps you to identify it if you're not sure. But on your paper, it looks the opposite way around, the right and the left. Now, the 2 top chambers, we've got the right atrium over here, much smaller than the ventricles. And we've got the left atrium over here. And then at the bottom, we've already labelled the left ventricle with that thick muscular wall to contract with a greater force. And here we've got the right ventricle. So these are our 4 chambers, should be super easy to label them. Let's go to the blood vessels next. Now, there are 4 key blood vessels carrying blood into and out of the heart's chambers. So the green one, of which there are 2 branches, you can see one at the top going into the right atrium and one at the bottom also going into the right atrium. This is the vena cava. The one at the top is called the superior vena cava. The one at the bottom is called the inferior vena cava. You can just say vena cava. And the vena cava is carrying blood into the right atrium. Now remember, this will be deoxygenated blood because it's coming from the body into the right atrium. And we know the right side of the heart deals with deoxygenated blood, right? So this is the vena cava here, or the vena cava, bringing blood into the right atrium. The blood's going to flow from the right atrium through these valves, which we'll label in a second, into the right ventricle. And then it's going to leave the right ventricle through this purple blood vessel here. And this is going to be the pulmonary artery. And there are a few tricks to remember that. It's carrying blood away from the heart. Away starts with an A, artery starts with an A, and it's going to the lungs to become oxygenated blood. So it's going to be pulmonary, right? Because pulmonary is related to the lungs. The blood then goes to the lungs in the pulmonary artery. So it's coming out here, goes to the lungs, picks up oxygen as it diffuses from the alveoli into the capillaries in the lungs. It's then going to return to the left side of the heart. The left side of the heart deals with oxygenated blood because it's come from the lungs. It's going to enter into the left atrium via these blood vessels here called the pulmonary veins. Again, a few tricks. It's coming from the lungs, so it's pulmonary. It's going into the heart. Vein ends in. They carry blood into the heart. Remember, this will now be oxygenated blood. The blood flows into the left atrium. It goes through this valve here. It goes down into the left ventricle and it leaves the left ventricle through this artery, which is shaded in red. This is the aorta. It's the main artery with the highest blood pressure, leaving the left ventricle and carrying blood all around the body, oxygenated. And it's an artery. Aorta begins with an A, so that's easy to remember, and it's away from the heart. Let's label the valves. So there are a set of valves between each atrium and each ventricle. You can see a set here and another set here. These are the atrioventricular valves. And there's another set here, which I'll just put AV valves. Easy to remember because they're called atrioventricular valves. They are between the atrium and the ventricle, and you've got a set on each side. And then you've got this set of valves here. You've got valves at the base of the pulmonary artery and valves at the base of the aorta, and these are the semilunar valves. And again, you've got two sets of them, one at the base of each of those arteries. Okay, now we know how to label the heart. We've got our 4 chambers, our 4 main blood vessels, and our valves. We've also gone through the 3 stages of the cardiac cycle. Let's get into it. It's really important that we understand the role of valves in the cardiac cycle. Now, valves ensure blood flows in only one direction, or we can say they prevent the backflow of blood. So blood can only flow through them in one direction. Now, a valve will open when the blood pressure is higher above the valve or on one side of the valve. So you can see here, you've got a higher blood pressure above the valve. It's going to force it open. So the blood pressure is higher on this side of the valve and lower on this side of the valve. It's like a set of swing doors, right? If the pressure is higher behind the swing doors, it's going to push those swing doors open, and that's going to allow the blood to flow through. But if you look at the diagram below, the valve will close or snap shut when that is reversed. So when the pressure is now higher on this side of the valve and the pressure is lower behind the valve is going to snap shut to prevent any blood going back in the wrong direction. And this is really important to remember when it comes to the cardiac cycle. But think of it like swing doors, right? And students in a corridor. If you've got lots of students behind the doors, they're going to be forced open. But once the students go through those doors, they're going to be forced shut behind them. Think of it like that, but blood flow. Okay. Now, when we think about the cardiac cycle, this is how I like to teach it. We need to think about 4 things. We're going to go through them. The movement of blood, the contraction of the muscular chambers, the pressures in the chambers, and the opening and closing of valves. So let's go through them and piece our cardiac cycle together. Let's do the movement of blood first. So blood is going to flow into the atria. Remember, this is happening simultaneously. So blood flows into the atria. It's then going to flow through the atrioventricular valves into the ventricles when those valves are open. It's then going to flow out of the heart in the arteries. So the purple artery is the pulmonary artery. Blood's going to flow from the right ventricle into the pulmonary artery through the semilunar valves to the lungs. And at the same time, blood's going to flow from the left ventricle out through the aorta, through the semilunar valves, and all around the body. So that's the blood flow. Now let's think about contraction of muscles. And I'm going to put all this together on a slide for you, by the way, so you've got it all written down. So in terms of our stages, we had atrial systole. So the 2 atria are going to contract. I'm going to say first, but remember this is a cycle, so you can kind of start it anywhere. But it's logical to think atria contract first. Then the blood's going to move into the ventricles. And then the 2 ventricles are going to contract simultaneously next. That's ventricular systole. Then obviously, the semilunar valves are going to be open, so blood's going to flow into the arteries, and at that point, all chambers relax diastole. So we have atrial contraction, then ventricular contraction, then when blood moves into the arteries, we have diastole, all chambers relax. Now, this is all coordinated by valves opening and closing. And valves opening and closing, that's going to be determined by pressure in the chambers. So this is where it gets a little bit trickier. But I'm going to see if I can explain this clearly. Let's think about pressures and opening and closing of valves, okay? Let's just look at one side of the heart to do this. So let's look at the right side together. So blood is flowing into the right atrium. So the right atrium is filling up with blood. And because it's filling up with blood, the pressure in the right atrium is going to be higher than the pressure in the right ventricle. And remember, if the pressure is higher behind the valve, that's going to push the valve open. So when the pressure in the atrium exceeds the pressure in the ventricle, the atrioventricular valve opens, it's forced open, and that means blood can flow through. Now the atria also contract, okay? So not only are they filling up with blood, increasing the pressure, but atrial systole takes place. The atria contract, reducing the volume of the atria. So the pressure increases even further. This is why the atrioventricular valves are open and blood flows into the ventricle. Okay, and this is happening on the left side at the same time. Now, blood has moved into the ventricle. So the pressure in the ventricle is now increasing, right? Because it's filling up with blood. So what's going to happen to the AV valve? It's going to close because the pressure in the ventricle now exceeds the pressure in the atrium. So the AV valve shuts to prevent any backflow of blood from the ventricle into the atrium. And then the ventricles contract, ventricular systole, the pressure increases even further. And now the pressure in the ventricle exceeds the pressure in the artery. So the semilunar valve is forced open. And as the ventricles contract, because the semilunar valve has been forced open, the blood will flow from the ventricle into the artery. But now the pressure in the artery is greater than the pressure in the ventricle, which forces the semilunar valves shut. So when all the heart chambers relax, no blood can flow back into the ventricle from the artery. Now we're putting everything together here, right? We're thinking about blood flow, contraction of the muscles, the pressure in the chambers, and what that means for valves opening and closing. This is what you have to be able to do. Let me show you it all together, and feel free to copy these notes down or screenshot this slide because this is a total overview of all of those things. Let's go through it together. Again, I'm going to start with the atria filling up with blood. It is a cycle, so you could start anywhere, but let's start there because it makes sense to me. So the atria start to fill up with blood, so pressure will start to rise in the two atria. Because the pressure is higher in the atria than in the ventricles, the AV valves open and blood will start to trickle through into the ventricles from the atria. The atria then contract, which is called atrial systole. That increases the pressure even further in the atria, forcing more blood into the ventricles to make sure that all the blood goes into the ventricles. So now the ventricles are filling with blood, right? And the pressure starts to rise in the ventricles as they fill with blood. And remember that when the pressure is higher in the ventricles than in the atria, the AV valves will close because the pressure is higher in the ventricle than the other side of the valve in the atria. So the AV valves close, and this prevents backflow from the ventricles into the atria. Because when those ventricles contract, we do not want the AV valves to still be open because blood would go back into the atria. Then we have ventricular systole, so the walls of the ventricles contract. Obviously, that's going to increase the pressure even further in the ventricles. And when the pressure in the ventricles is higher than the pressure in the arteries, the pulmonary artery or the aorta, the semilunar valves open. So as the ventricles contract and the semilunar valves open, the blood can then flow into those two arteries. The ventricles will then relax. This is diastole. Pressure will decrease in the ventricles. Blood could start to flow backwards from the arteries into the heart. But remember, because the pressure is higher in the arteries than in the ventricles, the semilunar valves have closed. So even when the chambers of the heart relax during diastole, the blood does not return to the ventricles. We are ensuring that blood will only move in one direction through the heart, from the atria into the ventricles when the AV valves open, and then from the ventricles into the arteries when the semilunar valves open. It will never flow backwards because the valves close behind the blood, if that makes sense. Hopefully these notes are sufficient now to help you understand. Remember the direction of blood flow, the muscular contractions of the heart, the pressure changes, and the valves that are opening and closing. Now let's have a look at a graph that comes up on the exam. If we have a look at this graph together, we can see that we've got pressure changes in the cardiac cycle, so pressures measured in kilopascals. We've got the 3 stages of the cardiac cycle: atrial contraction, ventricular contraction, and relaxation of all chambers. And we've got the pressure in 3 different parts of the heart: the atrial pressure, or the pressure in the atria, the ventricular pressure, and the aortic pressure. So this is the artery on the left side of the heart. So we're looking at pressure changes in the left side of the heart on this graph. Don't confuse the atria with the aorta. It's easily done. They look very similar, but the atria is the chamber, the top of the left side of the heart, and the aorta is the artery that blood flows through from the left ventricle. Now, wherever you get one of these crossover points, a valve is either going to open or close. So if we start with this one here, what this is showing us, if you look at the lines, is the orange line, which is the ventricle pressure, has just exceeded the purple line, which is the aortic pressure. So this is telling us the ventricle pressure has gone above the pressure in the aorta. Now, when the pressure in the ventricle is above the pressure in the aorta, that's going to force the semilunar valve open and blood will flow from the ventricles into the artery. But this is telling us, this crossover point, now the pressure in the aorta, which is the purple line, is exceeding the pressure in the ventricle. And this is because the blood has moved into the aorta and the ventricle is relaxing, right? It's emptied of blood and it's relaxing. So when pressure in the aorta exceeds pressure in the ventricle, the semilunar valve closes so that during that diastole or relaxation, the blood does not flow back into the ventricles. Let's move down here. If we look at these lines where they cross over, the pressure in the atria, which is the purple line, is higher than the pressure in the ventricle. That's going to force the AV valve open. So blood is going to be flowing from the atrium into the ventricle once that happens. And then back to here, the pressure in the ventricle has now risen above pressure in the atrium. That's going to force the AV valve to close so that when the ventricle contracts, the blood cannot go back into the atrium. So this is how to interpret this kind of graph. The crossover points mean that a valve is going to open or close. And you need to figure out where is the pressure higher and where is the pressure lower. Make that comparison, okay? Because, for example, here, I'm looking at the lines and I'm thinking, right, the pressure in the atrium is higher. It's just gone higher than the pressure in the ventricle. I can then picture that on the heart and think, right, that's going to force the AV valve open, and that means blood is going to move from the atrium into the ventricle. But back to this one, as soon as the pressure in the ventricle starts to exceed the pressure in the atrium, the AV valve closes to prevent backflow of blood. Let's see if we can do it ourselves on this graph. We've got to add descriptions for each label. So let's go through them. At A, I can see the pressure in the ventricle has gone above the pressure in the aorta, the artery. So what's going to happen? Have a little think. If the pressure in the ventricle is exceeding the pressure in the aorta, that means the semilunar valves open. Okay, and this means blood is going to be leaving the left ventricle and going into the artery as the ventricle contracts. Then let's go to this one. Now I can see the pressure in the aorta is higher than the pressure in the ventricle. What's going to happen? The semilunar valves close to prevent the backflow of blood from the artery, the aorta, into the ventricle. Because remember, at this point, the ventricles are relaxing, hence why the pressure in the ventricle is dropping so sharply. They're relaxing. The danger is the blood could flow back down into the ventricles. It won't, because at B, the semilunar valves have closed to prevent that from happening. Now at C, I can see the pressure in the atrium is exceeding the pressure in the ventricle. So if the pressure is higher in the atrium, which is above the ventricle, then the AV valves open and blood will flow from the atrium into the ventricle. The ventricle will then start to fill with blood before it contracts. At D, the pressure in the ventricle has just risen above the pressure in the atrium. So at D, the AV valves close so that as the ventricle contracts, there is no blood flow back into the atrium. And I can see what's happening as the ventricle contracts. The pressure in the ventricle exceeds or increases rapidly. I hope you have found this useful. The only other thing to say for this video is you can calculate heart rate from one of these graphs. And the way we're going to do that is we're going to use the graph to figure out how long one complete cardiac cycle takes, and then how many of those could fit into a minute, because heart rate is beats per minute. So let's try and find 2 points on this graph that are the same. So for example, here, 0.1, I can see at that point the pressure in the ventricle starts to increase steeply, and I can see that repeated here at 0.9. So I'm just kind of looking to identify 2 points on the graph that are the same. The easiest 2 points for me to identify there were the rapid increase in pressure, which is marked X, and then I can see that happening again at the point marked Y. So I can see the cycle is repeating again, right? So that tells me that the length of one cardiac cycle is from 0.1 to 0.9 seconds, which I don't really have to calculate that. I can work that out. But the length of one cardiac cycle is therefore 0.8 seconds. So how many fit into a minute? What is the heart rate? So there are 60 seconds in a minute. I just divide that by the time taken for one cardiac cycle to see how many would fit into a minute. And that would give me a heart rate of 75 beats per minute. Guys, make sure you're following, make sure you've got your notifications switched on. I'm going to be posting another video to help you with year 12 revision, paper 1 revision, before it happens this week. So yeah, check it out, and I hope you find these useful.